All right, so this is lesson 3.1, and we are in this lesson going to learn about functions and what they are. So before we get into our linear equations unit, relationships unit, it's important to understand what a function is. So first we have to know that a relation is a set of ordered pairs. For example, the table below shows a relation. And you can write these relations as coordinate points. So one coordinate point would be 0, 4. An x value and a y value. One coordinate would be 4, 0, x value, y value. 8, negative 4, x value, y value. And 12, negative 8. So you can have a relation in many different forms. You can write them as coordinate points. You can write them as in a table. You can put them in a graph, anything like that. So a function is a special type of relationship in which each x value has exactly one y value associated with it. So the easiest way we like to explain it is thinking of function and equations as machine. If you provide an input, the machine will give you an exact output. A function is a relation or an equation in which each input represents exactly one output. So each input, we call it x usually, represents exactly one output, which is we call usually y. So for example, if I come up with an equation or an expression and say that this function or this machine or this equation is x plus 3, okay? And my input here is x and my output out here would be y. And we can put y equals, right? So if I chose a specific number like 5, if I put 5 into my machine, and if I replaced it with x and I did okay, then that means I'm doing 5 plus 3, it would spit out the number 8. Okay, so a coordinate point we could say for this function would be 5, 8. Because when I put 5 in for x, it pops out 8 for y. Okay, so if you put a number in like, let's say 10, so if I put 10 in there, 10 in for x, I would pop out 13. So another coordinate point for this function would be 13. And notice, it doesn't matter what number I put in here in this function, I'm always going to get out a different number. I'm not going to get out, I'm not going to put another 5 in here and get out like 10 or something. 5 is only going to have the output of 8. And so you could do another number too. Say you did like 7. If I put 7 in this function, it pops out 10. Okay, so it's always going to give me the same number for the same input. It's never going to give me two different outputs for a number. Okay, so this is a machine we call a function. So if you're identifying functions, you can identify functions in different ways. You can look at tables like this, and so you have different points in here. And if it's a function, that means each x value should only have one y value. So if you look, negative 3 has a y value of 4, negative 1 has a y value of 0, 1 has a y value of negative 4, and 3 has a y value of negative 8. So we can say table A is a function because each x value has one y value. Okay, and so if we look at a table like table B, we can see negative 2 goes to 4, 0 goes to 0, 4 goes to negative 4, but negative 2 goes to negative 8. And so you see negative 2 has two different outputs. So we can say table B is not a function because negative 2 has two different outputs. And if you're having trouble thinking, all right, well, what does that even mean? I like to think about them in like metaphors. So say we have an input, and these are called mapping diagrams of students. And we have outputs of classes, right? So maybe, let's see, we have, Rick, Mick, and Joe. And we have classes such as science, math, and English, ELA. Okay, and so I'm going to say Rick goes to science, Mick goes to math, and Joe also goes to science. So this is a function because each input or each student has one output or class. So like schedules are functions. What would not be a function if we had students and classes again, so science, math, ELA, would be if Rick went to both ELA and science. Clearly Rick cannot be in two places at once, so this is not a function because Rick can't be in two places. So that's just kind of like a non-math example of a function. All right, and we'll talk more about different types of functions in class. So let's go through some examples. It says, determine whether each relation is a function or not. Explain your choice. So I'm going to look, and I'm going to look for if each input or x has one output or y. So if I look down here, I have 0, 1, 2, 3, 4, and they all go to different places. So number 1 is a function. Okay, and because you can say each input has one output. If we go over to number 2, we look 0 goes to 0, 1 goes to 1, 1 also goes, or 1 goes to -3, 1 goes to +3, 2 goes to -6, and 2 goes to +6. So this is not a function. Because 1 goes to 2 places and 2 goes to 2 places. So they both have different outputs for the same input. Okay, and if I go here, it looks like each number has one output, so this is also a function. All right, so that's tables. If you're looking at tables. Graphs are a little different because they're pictures. So looking at x and y values, x values are always your horizontal axis or your left to right axis. And your y-axis is always your up and down axis, right? So each x only has one y. That means on my x-axis, there should only be one y value. There shouldn't be two. So there can't be one up here and one down here. There can only be one y value. So we use what's called a vertical line test to see if graphs are functions. Okay? So if I can draw a vertical line anywhere on my graph and only hit it one time, it's a function. And that's because each x only has one y. Again, for number 5, if I draw, even though it's curved, if I draw a vertical line anywhere, it will always only hit one time, no matter where I draw it. So again, this is a function. Okay. However, if you look at a graph like this, if I draw a vertical line right here, notice I'm hitting my graph in 2 spots, which is telling me this is not a function. And to kind of explain that, say this point was -4, right? If x is -4, it has a y value up here of maybe 2 and a y value down here of maybe -2. So it can't, -4 can't have more than one output, so that's why the vertical line test kind of tells us if it's a function or not. So that would be a graph that's not a function. Okay. Number 7, these are what's called a mapping diagram. X is usually on the left and your Y's are usually on the right, or inputs, outputs. Because each number is only going to one letter, this is a function. And a number 8, if you look, number 1 is going to 2 places. So 1 can't have more than one output, so this is not a function. And finally, if I look at this graph, this is a special graph. This is this vertical line is right here. If I do the vertical line test on this graph, if you look, this vertical line passes this line all the time. So this is not a function because it passes that vertical line infinite amount of times. Okay. And so similarly, we can look at relations or just coordinate points. So for example, in number 10, I'm looking to make sure each x only has one y value. So -2 only goes to 1, 0 only goes to 1, 1 only goes to -2, and 3 only goes to 4. So that's a function. You could also, if you wanted to, make mapping diagrams of these and put all your inputs in one. So -2, 0, 1, and 3. And all your outputs here, 1, -2, and 4, and kind of draw arrows. So -2 goes to 1, 0 goes to 1, 1 goes to -2, and 3 goes to 4. And since each input only has one output, this is a function. So you can kind of do it that way too. If you look at something like number 11, you might notice that 9 is here twice, but notice 9 still goes to 27. So that's really only one output. 27 is only one output. So again, this one is a function. If you look at this next one here, number 12, this one you see 8 goes to 14 and 8 goes to 21. So this is an example of not a function. Okay. So that's we kind of ran through all of the situations here where you have tables, graphs, mapping diagrams, and relations or coordinate points. Okay, so your practice is really just identifying if something is a function or not in all different forms. Okay, so as we kind of talked about before, we can use that vertical line test. So I'm going to go through a couple more examples of vertical line tests to tell if it's a function or not. So in number 11, if I draw a vertical line anywhere, that only passes once. That only passes once. That only passes once. So this is a function because no matter where I draw that vertical line, it's only going to pass once. Okay. Same with number 12. Number 12, I can draw the vertical line anywhere and it will only pass one time. So this is a function. Number 13, however, I can draw a vertical line here and it hits the graph here and it hits the graph there. So this is not a function because this x value here would have a y value up there and a y value down there, and that means it's not a function. Number 14, for the same reason, I can draw a vertical line. Look, it hits twice right there. So this is not a function. All right, so then you might have relations like this, and it might help you to also plot these. So I can plot 1, 5, which is here. I can plot 2, 9, which would be up here. And I would plot 1, 6, which would be here. And if I wanted to see if this was a function, I might draw a vertical line. If I draw my vertical line right here, notice it hits in 2 spots, which is telling me this is not a function. And you can tell that even just from looking at the coordinate points because 1 goes to 5 and 1 goes to 6. So 1 has 2 outputs. So then again, we can look here. So I have 3, 4, -2 and 1, and 5, 4. And I can draw a vertical line through any of those points and it will not hit another point, so this one is a function. So those are just a couple more examples of how you can tell if a graph is a function or not using the vertical line test. So 3.1 practice is just identifying if something is a function or not.